for median of two sorted arrays. There are two sorted arrays, nums1, nums2 of size m and n respectively. Find the median of the two sorted arrays. The overall one-time complexity should be O of log m plus n. They tell you the running time is. You may assume that nums1 and nums2 cannot both be empty. Okay. Yeah, I mean, I think this is, excuse me. This is a kind of a very standard-ish problem for better or for worse. Though there is some like weird, it's just a lot of, not a lot, but a couple of edge cases to consider, which is like, the definition of medium on given number of elements in an array. But otherwise, well, yeah, let's start with one array. Where if it's sorted, then, well, it's just a medium element. But now you could kind of do like a thing where you like almost binary search E and try to divide it. And my watch is always telling me to stand up. To binary search thing E to be like, okay, so this is my thing. Where is it in the other way? And then kind of two-finger it so algorithm it so that like you find the endpoints and so forth. But yeah, you actually don't have time for heaps because so the suggestion is that we think of heaps. I mean, you kind of like in a way if you because the array is already sorted. So the reason why you don't have time for heaps is because you have to put everything in a heap, and that's at least of, well, just reading the inputs of n, right? So you actually don't even have. I mean, and if you put it in heaps, then it'll be n log n, which is already slower than this. The thing that you could take advantage of this is that both the arrays are already sorted, so you don't need to read the entire array. So you don't need to take that O of n penalty, and you could, O of n penalty, because you could randomly access certain points of it. So yeah. Oh man, my watch just told me that I already stood up, even though I clearly did not stand up. Maybe my hand waving is enough exercise for the hour. Yeah, are these all integers? Yeah, I guess so. I guess the double is just for these cases. So that's one way to do it. You could actually just probably binary search, or not binary search, but what's it called? Bisection. Yeah, maybe I'll do it that way because I like to do it that way, and I'm a little lazier. Though this edge case may be tough. Because the way that I'm thinking of is that in order to so for bisection, which is similar to binary search, but it's more of a numerical analysis thing, is that I mean, maybe it's just the same, but did Newton do it? I think maybe it's a Newton thing. I don't know, but for yeah, we have some function f of x that is well, for bisection, it just has to be monotonically something, like monotonically increasing or decreasing, and then you could kind of because that is either increasing or decreasing. In this case, it's increasing. I don't know. I always don't know which way the camera is, so my hand waving may be mirrored. But yeah, you could kind of divide your search space in half every time, and therefore bisectioning the plane, or yeah, and so forth. In this case, your f of x, you can just do like some k amount of those, each of these probes, and each of these probes can, for x, it'll return, say, the number that is number of numbers that is smaller than x, and then you kind of do this k times, and then eventually you just get the median, because and this function costs log of m plus log of n times. Yeah, which is, I guess, Yeah, which is I guess equivalent-ish. Maybe technically slightly faster, depending how they want to define it. Yeah, so that's pretty much it. And then once you kind of do that repeatedly, uh, then you could kind of, I mean, that's it. Yeah. And you could bind it because the arrays of nums1 and nums2 are sorted. You could do that in log n times because that's just literally binary search on the bisection. I guess there's two binary searches, but in this case, you only need to do a fixed number of binary searches. So that's why it ends up being k times this thing, or log m plus log n, where k is some constant, which is related to your word size, which in this case is like, if it's an integer, then it's just 32, right? So yeah, cool. No, let me get this set first. And may have the special case a little bit for even number of elements, but it should be trivial. Or like we could cross that bridge when we get there. So okay, all right, let's call these heads. I guess they don't tell you what the thing is. Then actually, technically, maybe not even. Could be negative. That wouldn't put it past them to be negative. Yeah, okay. Sorry, I got distracted by a ping and gotta turn off screens. Focus. But okay, let's just go with that for now. I probably want a helper function anyway. Is what we want is okay, n is equal to so now if this so median should be roughly. We might have to play around with it a little bit. But okay, so this number is bigger than our target number, which is the median. Then that means you're on the right side. So you want to move. You want it to be smaller, so you want to move the tail. Okay. This is not the answer. It's just a placeholder. So don't think I have to double check some stuff. But okay. The color's a little weird. Okay. Oh, this is also a time for me to maybe use also learning C++, STL a little bit. So what's that thing called? Lower bound. I know how to use lower bound kind of, but does that also give you the index? Then I don't have to do it manually. And for you just joining me, I'm just Googling now. As I mentioned before, I try not to. I mean, I'm not ashamed to Google. It's just I don't want to put it on screen because then sometimes I have sensitive stuff that Google results put up. But I hope y'all understand. Okay, so that's actually behave what I expect with the minus dot begin. Okay. Um, okay. Oh, X. Oh, minus. And at this stage, I'm just kind of try to get something up and running, even though I know this may be very prone to off by ones. Let's see how that happens. I guess for this example, it's not interesting. Oh, yeah. I guess this will never converge for some whatever. But actually, the cool thing you could do here is knowing that if you do it just like I don't know 100 times, it should be okay. Because afterwards you're beyond double anyway. It's either that or I just have something really wrong. So, or like I've just sign flipped, which happens sometimes. But that's fine because you could fix that pretty easily. Okay. Okay, so I think the odd case. I don't know. I'm still not convinced actually, because like I said, I'm really trying to be a little deliberate around off by ones, which I'm just bad at in general. And this could be just be a number between 2 and 3. It doesn't have to be 2.5. I don't think. Okay, which is roughly maybe expected. Because it depends how you do the thing, but. Okay. So we have the numbers that are roughly right. I guess my question is, let me just put like more numbers just to, oh, these are sorted, so I can just put random things. Or at least I have to do random things in increasing order. Nothing about dupes, okay. And one of them could be empty even. So they're roughly right. I have to handle the even case, which is fine. Okay. Okay. How do I want to? The top questions. How do I want to handle the even case? Because this skews the other way. It makes sense because it wants the number that is strictly higher than the median, which in this case is 4, so 2. So it wants the first number that is on the second. So maybe just maybe we could do it twice. Once looking for the nth number and once looking for the median number and once looking for the median minus 1 number. Is that cool? It should be okay. But if I do that, it's mostly out of laziness, to be honest, because there are definitely cleaner ways to do it. But three, so this returns 1. So okay, that actually this is maybe should be right for odd number things, but okay, how do I clean this up for even number elements? Am I that lazy? Maybe I am. Yeah, I'm just gonna run it twice. Don't know if I try to also decide if yeah, like if I was in the interview and I'm doing this, what would the interviewer say? I mean, you could roll into one loop, but then like I think computationally you do the same. You just do twice as much work in one loop, which I don't know at a certain point. Then like Then are you saving something? I don't know. At least I'm doing it kind of clean. If 10 is odd, then we just return this thing. Nose. So we don't need a nose, but otherwise return is plus. Oh, and then you average it, so over 2.0. Oh, doop de doop. There we go. We did fix that one. Why do I not have more even number cases? Is it just random? Or is it? Okay, let's repass all these. Let's try another one just for kicks. This one does not between one away. So it should be like what? 11.5 or something? No. Oh no, not 8.5 maybe? Yep. Okay, let's just see. Let's roll the dice. Okay, cool. Oh man. I'm way good on memory usage though. With the time that, I mean 44 milliseconds, I'm not gonna stress it to be honest. But because, maybe I will have to take a note to see if you could do anything clever. I mean, there's something you could clever with the way, with just like moving around the arrays to get the median, but I think this one is also kind of cool the way I did it. Even though I don't know how to do an interview. Excuse me. But yeah, let's go kind of retro this problem a little bit. Actually, I think my code is clean-ish. I mean, there are minor things I could clean up. Like there's some stuff that's a little, and magic constants all over the place. So that's something I definitely. Oh, and I didn't even delete these, but so definitely I could clean up stuff. Oh, like this is not even used anymore and stuff like that. I think my focus is generally just to get it out. But yeah, so there's definitely a lot of clean code or code that I could clean up a little bit, but in general maybe. But structurally, I think everything's okay. I have good modularization. I think like I break things out into components, and I don't really reuse anything. I mean, I reuse everything. I don't really have much copy and paste, which I'm happy with. Excuse me. Yeah, I mean, yeah, I'm okay with that. Yeah, excuse me. Yeah, in terms of complexity, as I said, it is k, in this case, k being 100 to 200, which is good enough for binary search, because you divide it by 2 every time the size of the search space, times log m plus log n, which is the cost of one of these things, which is this cost really. This is all this is log m plus log n, right? Really actually straightforward kind of way. But I was happy that I learned this, because I feel like I've been meaning to learn lower bounds and use the library more and stuff, writing my own code for binary search for stuff like this, which is something I do too much or used to. But of course, in an interview, you should ask your interviewer what they prefer. So that's the complexity. Space, I don't use any extra space other than constant number of space or constant amount of space more, which I guess matches with the memory usage. Yeah, I mean, I might review this later for the other solution, but I think in general I'm happy with this. I think, I mean, these are, I think, these are problems that are, low numbered because they're early in the Leetcode existence. So I think these are, and this is a problem that like I've heard about before. I haven't seen an interview personally, but I've definitely heard of other people giving it. So I think like you should know it just because it's something that people will ask. I think there's some like the only thing I would say is maybe some kind of uh, I don't know, some kind of game theory, reverse psychology thing is like if you don't want to study this because a lot of people are like, oh well, we've given this problem way too often, so we don't give this problem anymore, kind of thing. Then like maybe you don't have to study it, but that's up to you. I mean, I think you log in. Yeah, that's true. That log m plus log n is greater than log m plus n. Uh, yeah, I think you have to do something with the arrays, but um, hmm, it's a little weird too, because yeah, it is marginally bigger for sure. So in terms of kind of optimal code, it's not, but it's just so I don't know. I think at some point, I mean, and this is kind of me trying to figure out pragmatic things in general. Like, log of 2 to the 64 is 64, right? Which is, by definition. So like the difference between log m plus log n and log m plus n is, I don't know, like fractions of a constant that like I generate in theory, unless like you could really justify the difference, then but in terms of like complexity, you're right, and you have to do that other thing that I was talking about with the like in an interview, maybe you point it out just to kind of have that conversation going on, and maybe it's a good conversation, but yeah, because you definitely have to do like like okay, let's take an element in nums1 and then kind of like figure out how many um, where does it fit in nums2 and then kind of work backwards and then kind of uh, uh, do it that way. It was just kind of a little awkward, but maybe I should practice that next. But